What are critical regions and acceptance regions in hypothesis testing? And what is the critical value of hypothesis testing? In this video, we will try to understand that. Let's say, as per some study that was conducted a few years back, the average height of a person above 18 years in India is 165 cm. This year, we took a random sample of 100 people above 18 years and measured their average height. We found the average height of the sample is 172 cm. Now, we want to know whether the average height of a person above 18 years in India has changed and is not 165 cm. To determine that, we need to perform one hypothesis test. So, we will state two hypotheses. The null hypothesis will be that the average height of an Indian adult is 165 cm, and the alternative hypothesis will be that the average height of an Indian adult is not 165 cm. As we discussed in one of our previous videos, in this case we will perform a two-tailed hypothesis test. At this point, we need to decide on the significance level. We have already discussed the significance level and the p-value in one of our previous videos. The relevant links are provided in the description. Let's say our significance level alpha is 5%. So, we will take the distribution graph, for example, the t-distribution graph for a t-test, and we will shade the 2.5% area on both sides of the distribution graph as shown. After that, we will calculate our test statistic. Now, if the test statistic falls within the shaded region, we know that the results are significant and we will reject the null hypothesis in that case. The shaded regions on both sides of the distribution graph are called critical regions. Please note that for a two-tailed hypothesis test, the critical regions lie on both sides of the distribution graph, and the shaded area on each side of the distribution graph will be 2.5% for the significance level of 5%. For a left-tailed hypothesis test, the critical region lies on the left side of the distribution graph, and if the significance level is 5%, then the area of the critical region on the left side of the distribution graph will be 5%. And for a right-tailed hypothesis test, the critical region lies on the right side of the distribution graph, and if the significance level is 5%, then the area of the critical region on the right side of the distribution graph will be 5%. What are one-tailed and two-tailed hypothesis tests, and when to perform which test? We have already discussed that in one of our previous videos. The relevant links are provided in the description. So, the region under the distribution graph that is not shaded is called the acceptance region. If the test statistic falls within the acceptance region, we fail to reject the null hypothesis. Please note that after finding the test statistic, we compare the test statistic with the critical value to know whether the test statistic falls within the critical region. If the absolute value of the test statistic is more than the critical value, we know that the test statistic falls within the critical region, and we reject the null hypothesis in that case. If the absolute value of the test statistic is not more than the critical value, we know that the test statistic falls within the acceptance region, and we fail to reject the null hypothesis in that case. I hope this helps. Interested viewers who want to know more, please refer to the playlist Statistics for Machine Learning. You may also want to visit the website of the Security Buddy for more information. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.